I want to welcome everybody and tell you how really excited I am by this whole process. I'm happy that you all took time out of your day to come and visit. And what we really want to do is to talk about the Siemens engineering design curriculum. We partnered with Siemens a couple of years ago. We were having this long discussion about, how things are in schools and what we want to see as far as outcomes for students, and it kind of blossomed from there into a whole curriculum that's really just for schools to use. So we want to talk about this engineering design curriculum, and when we got started thinking about it, we decided that we had to come up with a method of helping teachers and allowing them to see what they needed and how they could help their students really meet the needs of local industries and get them prepared for further studies in 2 and 4 year programs. And so I just want to take a second to introduce you to everybody. My name is Tom White, and some people have already, familiar with my work, and the same will be true for the other folks that'll introduce themselves. But I'm really excited by the possibilities that this brings, and all the feedback I've been getting from teachers and how much they're enjoying themselves, working through this curriculum. I'm going to let Dick introduce himself. So go ahead, Dick.
Thank you, Tom. Good afternoon, everybody, and welcome to this first webinar on the Siemens curriculum. Tom and I have been working together for over 30 years, so we've got a long history of collaboration and doing good things for students and teachers. One of the things I noticed from the people who registered for this program today is we have teachers from 28 states registered for today. And we have people from, including the US, 5 countries. So it's quite a representation. So congratulations to everybody. Tom, go ahead. Oh, by the way, Matt, I think is in an airplane right now and won't be with us for a while.
Yeah, he might be able to join us when he gets that far. And Matt is he's the director of the Americas academic program, and I met him 5 or 6 years ago, and I had called him up and said, "Can I get a grant to use in the program that I was running at the time?" And he was just curious about what we were doing, and the one conversation led to other conversations, and he helped set up a mentoring program with people at Siemens for students in various schools, and he had a very similar vision to education as Dick and I. So it was a really nice mix, and I don't want to give the impression that he was the only one from Siemens, because they have a ton of folks that have helped us out with this. They're a small company. They have 350,000 employees, give or take a few, and they're in, they touch just about every segment of our lives on a daily basis. It's a lot of under the hood stuff, and their basic premise for this was they want to, generate the next generation of folks to come work for them. So the Siemens engineering design curriculum is, we put it together, and the basic premise was there would be no charge to schools for the curriculum or the software that goes with it. So with that in mind, we set up communications so schools can just very quickly fill in a form, and they'll have their license for the software. The curriculum is yours to use how you see fit. So far, just looking at the people who have signed up, over the course of the last few months. There are like the Girl Scouts to all kinds of schools. Some schools that are so small that they don't have a principal; they have just a teacher, and it's in 30 some odd countries on 6 continents. So it's all out there, and we're here to support you in your journey through this. The curriculum is project problem based. We give the students problems to solve, and we give the teachers instructions on how to do that. It's not intuitive at first. Once you get started and you get involved, you'll find that you'll really enjoy this method of teaching. The kids take charge of everything, and you get to act as basically the guide through this whole thing. And students, if they're responsible, they work harder, which is good for me. We've incorporated all the latest standards that we can find. And I know that a lot of teachers need to fill out lesson plan reports, and they want to know which standards are being addressed, and they want to know how you're actually doing that. So we prepared this so teachers can spend more time teaching and less time, on the paperwork end of things. Now, this young lady that you're seeing is from the state of West Virginia, and she was working on a project where they had to design a glider. And so through the whole process of design, they generate lots and lots of different possibilities, and then they narrow it down. And we'll talk about the design process that they follow in a little bit. So they have to do some research. So every project starts with some basic research about, what works, what have people done, what are some ideas, how do we go about putting things together, try some new things, and then they have to go through and they have to test it. Then they have to analyze, what they tested. Did it work? Did it solve the problem the way we wanted them to? And finally, they have to communicate that solution. And we phrase it as an authentic audience. So teachers sometimes are afraid of bringing outside people in, but once we get them started, they really like it, because it's one thing to explain to a teacher what you did. It's something else to explain to somebody from a local industry that actually works on things. And so a number of students who were doing that impressed the company so much that the companies reached out and said, internships, and can you come work for us, and are you 18 yet? And it's a lot of really interesting questions. Our goal was to make this curriculum appropriate for all students. It's not kind of narrowed down to only the best and the brightest, and we tried to make it so it would work in a variety of different classrooms. Now, this classroom that I visited, it was slightly bigger than a broom closet, and they had crammed 32 desks and chairs in the room, and the kids all piled in, but they had a wonderful time. They worked in groups. They shared things, they tried things, and I couldn't be happier with the results. We make extensive use of 3D printing. It's one thing to come up with a model. It's quite something else to make the model actually work or fit with parts that other students designed. So this was one team, and they were printing their first parts, and I just couldn't get over, how close they were to this 3D printer so they could actually watch it work. So we've managed to work with a couple of places that are making maker spaces, and they wanted to know, well, how do we do this? We've got all this equipment that we've gotten, but how do we help the students learn how to do this? So we worked with them to allow them to get started. So we're using this engineering design and problem solving process. And this project was something we called reverse engineering. So the students had to find something, take it apart, and measure it all up. And you'll see as we go through this that the students are doing a lot of sketching in what we call an engineering notebook. And they take all their dimensions and things, and then they can take it through a CAD system, take the output of the CAD system and take it to a 3D printer and print it. So the picture on the bottom right is a clothespin that they had reverse engineered, and they said the hardest thing was to print the spring. So they had, designed it. They, used all the modern tools to get the spring in there, and to get it and clean it up and put it in there was quite a job. And so as we looked at these skills that, we wanted to include in this curriculum, we found that, in talking with, colleges, I worked with a group of colleges in Georgia, and, it was Lanier Technical, was the 2-year school that was involved with it. And they have a requirement that the students present once. And the 4-year school that we were dealing with down there said that, well, a lot of their engineering students, they can't present their ideas, they can't talk about them. And so we talked about, well, how do we get more and more skill sets that people are really looking for? So we went to this National Association of Colleges and Employers to say, well, what skill sets, would you like to see? And if you look at it, of the top 10 skills, technical skills are really the number 10 piece. And of course, at that point, they're talking, can you work with Excel? Can you do, a lot of things? So, but they're really looking for people to take the lead in teams, being able to communicate both verbally and through written forms, your problem solving, any kind of, troubleshooting skills. Can you walk in and figure out what needs to be done? Are you flexible? Or, but these are the things that people are looking for. So we decided that the curriculum really needed to have all these things built into it. And we did that by saying, if the students run through this problem solving process on each of their projects, they'll still learn what we want them to learn, but they'll come out with those skill sets that really pique the interest. So the new Perkins legislation, they're looking for those kinds of skill sets. They're looking for the project-based learning. They're looking for all kinds of things. And so if you put that all together, this actually accomplishes that for us. And I just had to, throw this picture in. The Siemens folks are quite proud of this. This was a young woman in Alabama, and she took on a project to create basically a new foot for a young soldier who had lost it over in Afghanistan. And so she went through and she worked with him and a bunch of other folks, and she was able to create this artificial foot for this person. Now, when you stop and think about it, that's a pretty impressive thing for somebody who hasn't even gone to college yet. Some of you might have seen her on, I believe she was on the Today Show and a couple other shows, and they were really, people heard about this from a local news story, and it just went viral. So, the skill sets that they're learning are real. The ability to help other people are just exciting. And what I'd like to do first thing I wanted to do is give you some information on where you can download the curriculum from. So it's at siemensdesign.tomwhitestem.com, and that's where you can get it. And I'll put that up again a little later, because what I want to do right now, if this works, you always wonder if these things are going to work, but here's our contact information, and we'll put that back up. And
Tom, this is being recorded, so people will be able to see this again, right?
that's correct. So what I'd like to do at this point is to open up the curriculum. And what you're looking at now is the PDF of the curriculum. So it's a curriculum document, and basically we can navigate all through it. There's a table of contents, and you'll see that it's all interactive, and you can get where you need to go. So the first thing I want to do is to give you a view of what are some of the projects that we're doing. So this is talking about, in the first quarter, the first thing we're going to do is an engineering design process. So, and these are all links to various sections in the document. We take them through sketching and documentation, because in the design process, we spend a lot of time with pencils and sketchbooks to get ideas down and help us communicate with one another. Some of us are really good at it, some of us are not so good at it, but we all get better with practice. By the time we get down halfway through the first quarter, we're doing our first piece that actually we can talk with the 3D printer and start getting that excitement going in the rooms. Then we move on to just simple objects, and what we do is we tell folks that you got to make a choice. You can choose one of these projects to go with. There's enough projects in this curriculums to take up about 2 years. So, we give you lots of options. I know at one point in my career, I would get a little bored if I had to do the same thing all the time. And so this allows for different things, or even different groups of students to follow what they're really curious about. I think that's really a wonderful thing, because the more involved students are in choice, the more that they're going to learn. There's a project where they learn how to render. So they make photorealistic renderings of their pieces. And that really helps with the engineering, reports and things like that. We teach them how to do table-driven parts. And, so there's an example of where Excel is applied. So it's really nice to, show students that we use all kinds of software in a lot of different ways. The second quarter, we have them design a 3D puzzle of one type or another. We have them design a mold. Then one of the projects they could do is a coach's cart, and we have them do a reverse engineering project where they take something apart and everybody takes a part, to draw and design, and then the team has to put it all back together. That forces the discussions about tolerance and how do we use standards, and how things all work the same way. Third quarter, we're getting into simple machines. And so they're going to take a choice of one or two of these things that are already laid out. It's nothing is written in stone. And so if somebody comes up with a great idea, they can run with it. The next one, this ball launcher, is really another exercise in Excel where we do some math to make predictions about how far it's going to launch a ping pong ball and where it's going to land. So not only do they have to design and build this device, but they have to make sure that it works and does what they want it to do. We talk about gear systems. So, there's a wonderful gear tool in the software. So we talk about, well, why do gear systems work the way they do, and why do we use them? And this really gets into some of the science that's necessary to piece this all together. And then there's a merry-go-round project where they get a chance to not only design a merry-go-round, but they can design a whole playground. So once the class gets through with this, everybody takes a different piece, and then they can throw this together. So it's in the fourth quarter. There's a piece on structures and forces. So this allows us to do some testing to say, okay, we want to really design something so it works. So we have to pay attention, because if I'm going to design a playground for a child, I got to make sure that it doesn't, fall apart the first time they climb on it. We talk about a hybrid toy connector. So if you have Legos and you have Fisher Technics or any of the other systems, how does one attach to another? So let's design those. And then we give them some choices in these engineering systems. So one project is a centrifugal pump. Another one is automatic training wheels, where you design a training wheel system that will kick up, so you don't have to sit there with a wrench putting them on and off all the time. You can do them at your leisure. And then a few others. So each project, and I'll just take this one as an example, it's all linked. So here's the project that goes with this. So every project has an introduction, which talks about, well, what is this project about, and what do you hope to learn out of it? The purpose of the project gets into, say, to students and teachers, okay, this is what we're really trying to get at with this project. So in this one, we're talking about strength of different geometric shapes and some other advanced physics processes that people really need to be familiar with if they're going to go on to careers in this. We list the major concepts that we want students to be able to master as they go through this. We give a chunk of an outline of where does this fit in the whole course perspective, and what are they going to be doing. So they're going to be creating an engineering notebook. They're going to present you with calculations on the truss systems. They're going to create a 3D model of it. And they're going to basically construct this model. They're going to analyze it, and then they'll be doing a presentation of it. Then there's the standards, and the standards talk about which pieces. There's career and technical standards. Then we go into, of course I jumped ahead. The reading and writing standards, the next generation science standards, and we also talk.
And Tom, these are the standards in those disciplines that relate directly to this project.
Right. These are standards that are covered in this project. Right, and we talk about assessments, and we provide rubrics. And so every project is going to have an essential question. And the essential question generates the interest for students. We say, hey, if you can do this, then you can probably prove to somebody that you know pretty much everything that's going on. There's a student scenario, and basically that allows the kids to take on a role. So when we say you are, a team that's going to design and build this, if they get excited about it, they can go and do a little research in, a site like mynextmove.org and figure out, well, who does this? How much are they paid? Do they have jobs in my area? Are the jobs increasing? Are they dying a slow death? That type of thing. There's a daily plan. And the daily plan, gives the teacher kind of a overview of, what should be happening. And so the very first day is talks about getting, the students to understand that, there's a design process and, how are we going to set this all up? And, this is just a quick review by the time you get to the, fourth quarter, but in the very beginning, a lot of it is they really need to pay much closer attention to.
And Tom, those hot links in there are designed to help the teacher.
Yeah, yeah. So, basically, vocabulary terms would take you down to, here's all the vocabulary that we would want the kids to know
In this project.
in this project. Right. So one of the things that we have them do is, as a team, they go off and everybody researches different terms. They come back and they teach each other. There's a resource section, and basically the resources, we come down and we say, well, here's some bridge basics, some truss basics, design factors, engineering reports. So if I click on the engineering report, that should open up a website, and this one was technical writing. So this presentation here, this talks about the sentence structure you use in technical writing. And we've looked at these because, these make sense to people and it's understandable. So students will take a look at it and they'll figure out, what makes a good presentation.
And if you're in an academy model school where you're teaming with other teachers in other disciplines, like English, for example, what Tom just showed you would be a great tool for that English teacher to be working with those students on this project in that English class.
Yeah, and we see this used, in multidisciplinary ways quite a bit. Maybe not for the entire year, but at least for a project or two. The English standards call for, doing some writing and, non-fiction reading and things like that. So this is really gives them a lot of opportunity for students to do those things. There's another, piece that we've built in here. There's activities that help students guide through. So, when we click on an activity, it's like designing and analyzing beams. So we talk about forces, and then a little further on, we give some instructions for designing a basic beam through solid edge. And this allows students to begin to understand, how do you define those. A little further on, there's one that talks about, how do you analyze things, with the software? Because the nice thing about modern design is we can design it. We can say we're going to make it out of a specific material, and with the click of a button, it'll go through and do a finite element analysis and give us the results. And then let me just see if we can get to, oops. That's the button. Then we go in and, each one of these projects is going to have some math related to it and some science related to it. So in this one, we come through and we talk about, all right, so what are the formulas we're using and, what do they really mean? So this is good introductory physics. So if you wanted to, use it in your science class or tie in with the science class, that's will allow you to do that. And using this, type of thing, you can go through the formulas at the same time you're actually stressing and testing, and it makes for the physics to come alive. I know I, spent a lot of time doing physics labs when I was young, and It's much better when you can go outside and say, okay, I'm going to pick an engine up and I'm going to tie it to, this column over here, and it'll hold it or it won't hold it. So it allows for measurement. It allows for doing all kinds of things, and it takes it to a new level. And then there's always these little back buttons. So if I hit my back button, I can then say, all right, so I want to go to Q4. I was on the truss system, and now I'm back where I started. So it allows teachers to navigate through this relative ease. I think there's 738 pages in this one, so you need some kind of a navigation system. And PDF can go on the students' computers. The software that's involved in these, there's a student version that the students can download and put on their home computers. So if they're feeling like they should, work outside, then that'll work out okay. And so I'm going to put this piece up again so you get a chance to take a look at the link to go find these things. So this is the download link, and you'll notice there's two of them there. The first one is the Siemens Engineering Design. We finished that one last year. And the second one is the Siemens Manufacturing and Automation, which would be good for Career Center or for a place that really wants to go into, how does this all applied in a, like a sequence. So it's good for talking with, people satisfying Perkins requirements and pieces like that. Also, colleges, pretty much look at this and say, oh, well, this is what we want to see. And so there are a couple of colleges and schools that have got agreements already to offer students credit. And, these are credit by exam, I guess is the actual term. So since the college isn't teaching the course, they have to have some way to guarantee that the students have achieved, something that's worthy of college credit. So I've been talking for a long time. Does anybody have any questions?
Tom, why don't you talk a little bit about what could happen after this webinar, what we could do in the future, and how we might ask people to submit some topics that would be of need to them.
Oh, for feedback, yeah, we're going to be designing some social networking sites so teachers can post some of the great things that they do. Also be a place where you can say, this is great, but in my area we have this industry and we'd really like to offer a project on X or Y, and it's our goal to keep this happening so we can help schools meet the needs of their local communities. Is that what you had in mind, Dick?
Yeah. Tom, we got one question. Is the credit by exam an option for both courses or just the manufacturing and automation course?
Well, actually, the first course, the engineering design, there's an actual industry certification, solid edge cert. They have 3 levels of certification. The last one being professional, and that one needs a lot of engineering experience. But the first 2 are, once you get through with the course, the student should be able to sit for that exam and do pretty well and walk away with credit. So the short answer is, yeah, you could do a credit by exam to a local community college or 4-year school, kind of a partnership agreement. Because one of the things that
we've just started with the manufacturing and automation course, so there's not a lot of history on it yet. It just was released in time for schools to have access to it for this school year. So it's just, it's new. So it probably doesn't have um, had an opportunity for schools and colleges to have discussions about the credit by exam for the second course, but that'll be coming.
Yeah, there's a lot of interest because technical programs at colleges are expensive to run, and they want to make sure that they get a good quality student in, and so this fits their needs, and or, as a college professor, I can tell you one of our requirements was to go out and find partnerships with schools. So it works right into that. It fits their goals and needs, and it helps support your programs.
And when you're talking with college people, when you show them the technical standards that are in the projects, um, as well as the academic standards, but the technical standards really connects with them because that's what they're in the business of doing, is teaching students that. That really speaks to the rigor of the technical concepts that are in this curriculum.
So the good folks from Studica are going to record this, and they're going to make the link available. So if you need that'll be coming soon. And if you
We
have
got
any questions for us,
we have one more, Thomas. Are most high schools generally able to complete the engineering design course in a single year?
well, the short answer is yeah. You're not going to finish everything because there's a lot of things that are optional. Um, so it was really designed to allow you to pick and choose and work your way through. So an average, calendar year for a school, you could do this. If you have block scheduling, you could do it in a half a year, and your kids will be picking up speed as they go because they're going to pick up a lot of skill sets, and it's really kind of impressive to watch what they're doing. If you're on one of those extended block schedules and you have extra time, then there's extra projects, so you don't have to hunt for things for the kids to do. And I think you'll find that helps a lot in the long run.
One more question, Tom. What equipment is needed for the course? Is there a cost? If so, what is the estimated cost?
Well, we teamed up with Studica on that. We told Studica what we thought you might need to do everything. So there's like three 3D printers and things to do a lot of different projects. So what you need will depend on which projects you're going to do and how many students you're going to have in the program. So
But
so the
but
short
Studic,
answer is yes, Studica can give you a quote on this, and it'll allow you to figure out what the expenses are. Because I know a lot of schools already have 3D printers and they things like that, computer labs, networks, and some schools have bare walls, so the cost will be different for each one. But it's designed to use a very relatively limited resources. So we didn't want to break the bank, and we don't want to limit schools' ability to do this, or at least some of it, because you could conceivably say, well, I'm going to do a half-year course or a three-quarter-year course, and you wouldn't necessarily get all the equipment. So, but
but
the
one
kids
but
have a
one of the
chance.
but one of the things we paid close attention to was we provided Sudica with a list of everything that's needed, so they know that it's there. What's expected for each course, and they'll give you that information.
Hmm. So there are more questions. All right, let's see. There was one. I'm looking at it. How closely is it related to the SRED AC curriculum? Um, it's similar, only because Dick and I did a lot of work designing the AC curriculum. That's a 4-year program. This allows us the engineering design curriculum really focuses on engineering design, and I know a couple of schools that are using this before they get into the AC curricula, because they didn't think their kids were ready to jump right in and do some designs without some previous work. So one, they're using it in ninth grade, and then by 10th grade, they can go into like it's like a career tech type of thing. So this kind of preloads that and allows them to get that started. Any other questions?
Jackie, if anyone who's listening wants to suggest topics for us to do another webinar on, would they be able to send that information to you?
Well, they can basically send it to us.
Send it to us. Okay, that's even better.
Right, and we might even be able to, because I know I've discussed with Studica that we were talking about, well, some people might need a little bit of training before they go into this. So we were talking about ways to do it online. So you get a look at how this is accomplished, and then you can pick it up from there. So yeah, the more ideas we have, the better off it'll be. So you have any final words, Dick?
Well, no, not really, other than just to say, I would say that of all the stuff that Tom and I have done in our career, this is probably the best, and the best work we've done. And we'd be very, very anxious to hear from you when you're using this with students, how it's going. Give us feedback. Um, I know it's important to Siemens that this be something that is effective, and we would love to be able to share best practices. If you've got uh, projects that students are doing, you can send some pictures, even do a video. Anything like that would be very helpful to us. Getting your feedback, and the stuff that's great, the stuff that's not so great. Um, it's a living document, and it should be modified as needed. So your your experience with it is vital for us to know about.
And I want to extend my thanks for taking some time to visit with us this afternoon. And it's exciting to us that people are interested, and they think it might fulfill a need in their schools. And Dick and I have spent, I don't know if you combine our two lifetimes in education, we got almost 100 years, or somewhere as close to that. So
Scary.
that, yeah, it is, isn't it? Yeah, but we're still kicking. So
That's
at
right.
any rate, we appreciate you taking the time to spend with us. And if there are no more comments, we can end this. And feel free to contact us whenever you need. Oh, let me just throw our contact information up there. So feel free to copy our phone numbers down or our email addresses, and you can get back in touch with us.
Very good. And thank you, MW, for that very nice note. Okay. I think we're done, Tom.
All right, I'm going to mute myself and then I'll leave the names up there for a second. Well, if anybody's, copying it down and
Yeah,
obviously they're,
that's
you
good.
know,
That's good. Right there. Beautiful.